So we've defined what the equilibrium constant actually is. But I at least want to show you in practice how you would actually define it for a reactive system. Okay? And so what we're going to consider is a very general reaction. So where we have A plus B gives us C and D, and there's some sort of stoichiometric coefficients in front of each species. Okay? And so if we were dealing with an ideal gas reaction, our K, it's going to be in terms of all the activities for, each of the species in the reaction. And we know that for an ideal gas mixture, the activities are going to be in terms of total pressure over the standard state pressure times the mole fraction. So for species C, it looks like this, and then raised to nu C. Species D, it looks like this. And for all the reactants, they're going to be on bottom. Okay. We could factor out, because we know that this P over P naught term shows up sort of everywhere. And so we could rewrite the equilibrium constant in a simpler way, or a more aesthetically pleasing way, like this. Where for the reactants, since they're on bottom, just to avoid any confusion, you would write the magnitude of their stoichiometric coefficients. And then all the pressure terms, you would have P over P naught here. And then this would be raised to the sum of all the stoichiometric coefficients. Okay? So that's what it would look like for an ideal gas reaction. And so let's say if our reaction is once again that CH4 plus H2O yields CO plus 3H2. Our K would be YCO raised to the 1 times YH2 raised to the 3 over YCH4 raised to the 1, YH2O raised to the 1. And then for our pressure terms, we would sum up all the stoichiometric coefficients. So we would have 1 plus 3 minus 1 minus 1, and that would give us a power of 2. Okay? All right, and so that's what the equilibrium constant would be for that reaction, for an ideal gas reaction mixture. And I'll just state here that if you're dealing with a liquid reaction at ambient pressure, this part's important because it simplifies things a lot, then your equilibrium constant would just be that product of the activities, and your activities would be written in terms of your activity coefficient, xi, all raised to the nu I.